Okay, now on the board here, and this is going to be the same notes that are on for the e-learners, and I'm just going to run the video, but I'm still obviously talking to you guys. So what I'm writing on here, step 1, first thing we want to do is get the x squared by itself, because what we're doing is we're solving quadratics just like we've been doing, but a different method by finding the square root. Okay, so just a little bit of information. This isn't on the board, but Victor, go ahead. Just give me like your first couple minutes, but you're fine. You're fine. Now these are all perfect squares, and I want you to simplify it if it's a perfect square. If it's not a perfect square, it means it doesn't have an exact partner. Like the square root of 64 is 8. But one of the things that you don't think of, it's also negative 8. Because negative 8 times negative 8 is 64. And 8 times 8 is 64. And with these, we would use it. I think this is where I was supposed to hit pause. Normally, you don't use the negative when you're working with square roots, because just like with the Pythagorean theorem, the a squared plus b squared equals c squared. Even though you might not say, oh, I don't remember exactly how to do that, you've seen this before. It's working with right triangles and the lengths of sides. So it's the end result, like if you had b squared equals 64, then you would take the square root of both of those. And the answer for the square root of 64 is positive and negative 8. But if you're looking for the length of a side, it's just positive 8. So you never used the other one that was there, so you kind of forget that it's there. Here what we're finding is where the parabola crosses the x-axis. So you want both positive and negative, because it's going to hit the x-axis at 2 points. So remember, it's just like if I said write a variable, you know that there's an understood 1 there. So with these square roots, there's a positive and negative that you want to use both of them. So when it is a perfect square, square root of 49, I want you to write positive and negative 7. Square root of 81, that's a perfect square. You know that, positive and negative 9. But you don't so step 1, we want to get the x squared by itself. Okay, so for you guys that are here, get the x squared by itself. And then you're going to take the square root of both sides. So I'm trying to, if this is so important to me, I'm trying to simplify the boards, kind of maybe not even have the examples, because the examples, step 1, step 2, step 3. Your mind, the way you go about it doesn't change. So you don't really need an example per se to look at, just here, and then how do we get the x squared on one side by itself? You do the opposite operation. So on this example here, I mean, you need problems to go over, obviously. We want to get this by itself. In our minds, that's step number 1. So that's what you need to tell yourself, because that's where you want to end up. So we're going to do that and do the opposite operation. Okay, subtract 5 and get 3x squared equals 36. Now the goal is to get that x squared by itself, doing the opposite operation. Opposite of multiplication, division, blah, blah, blah. So here, we're going to, this is 3 times x squared. The opposite of multiplication is division. You divide both sides by 3 and get 12. Now, so step 1, get this by itself. And then step 2, take the square root of both sides. Okay, and your answer, this 12 is not a perfect square, so just leave it under the square root. So your answer is x is positive and negative the square root of 12. Does anybody know what those, I call them double squigglies? Mackenzie?
It means about.
Exactly. So this is the notation for about or approximately. You don't use it with perfect squares, like the square root of 64 is equal to positive and negative 8 because it's an exact value. Okay, so you can just leave it like this, and that's your answer. Okay, so example number 2, step number 1 right here. Get the x squared. So in your mind, in terms of what you're doing, you're telling yourself we want to get the x squared by itself. Well, how are we going to go about doing that? Do the opposite operation to both sides. So here, this is 4 times x squared, so divide both sides by 4. You get x squared equals 56. Now, 56 is not a perfect square, so step number 2, take the square root of both sides. There's a positive and negative outside of the square root. This equal sign goes to a double squiggly because it's approximately. So the values where this particular quadratic would hit the x-axis is whatever the square root of 56 is. I don't know. Okay, but it'd be at those 2 places. And then the last example here, example number 3. And we're starting pretty basic. They'll get a little bit trickier, but this is like a nice little puzzle. This is step number 1. So in your mind, you're saying get the x squared on one side by itself. You might not understand how to do that, but once you get the process down, then how to do it becomes easier. So get this by itself. So how do we do that? Do the opposite operation to both sides, whatever that is, to get this by itself. Divide by 7, r squared equals 5. Then step number 2, in your mind you're saying, okay, now we did step 1. Step 2 is what? That's what you need to be telling yourself. Okay, so you take the square root of both sides, and you get r is approximately or about, positive and negative. And you can just leave it under the radical sign. This is called the radicand, and that's the radical. You can just leave it like that. Okay? All right, so I have a few problems for you to do. And